We can also reflect over two other special lines. So we need to remember back some of our algebra and our y equals mx plus b. These two lines both have a y-intercept of 0. Think about it as a plus 0 here, and they have slopes of 1 or slopes of -1. So really they are these diagonal lines, up 1 over 1, up 1 over 1, that cut diagonally through 0, 0 here in this direction, or up 1, left 1, up 1, left 1, or down 1, left 1, down 1, left 1. And we have these reflecting lines here. We can also reflect over. Now these are a little bit harder to just count or to see, and so that is why we will look at the rules first. And the rules for these are, so the rule for reflecting over y equals x is you take your x and y of your original and it will become yx. So same signs, flip the order. So when I look at h, who is at 4, -4, 5, m is at -3, 1, and d is at -6, 3, then that means that m prime is going to be at 1, -3. H prime is going to be at 5, -4. And D prime is going to be at 3, -6. So same coordinates, just in the opposite order. And when you connect those dots, you can see I've got the exact same figure, just reflected across. Now, one cool feature that you can see here is from a pre-image to an image point that is perpendicular to the reflecting line and equidistant. So I could connect each of these like this, and it would be perpendicular, and these segments would be equal. So if you're thinking about folding it in half along that red line, that y equals x, that is how it gets transferred over. Now it doesn't matter if our reflecting line runs through our figure, we can still do the reflection. When we reflect across y equals x, we get our original x and y will become, this time when we switch the order of our x and y, we also flip-flop the signs. So switch the order and the signs. So when m is at -3, 1, m prime, and you may want to write these, is going to become -1, 3. So -1, 3 is where m prime goes. And h is at -4, 5. H prime, opposite sign, switch positions, is going to go to 5, 4. And it goes on the opposite side of the reflecting line, like you would expect if you made a heavy paint triangle and you folded it in half and ink blotted it, everything's going to transfer. Now D is at -6, 3. So D prime will go to -3, +6, -3, +6. And when you connect those dots, you still have the exact same figure, just in a new location. So those are your 4 special reflections. Translation is another kind of transformation, and we call this a slide. We are just going to slide this left and right and up and down. Again, it makes congruent figures because it does not change the size or shape. Our general rule for this is going to take our original, and we are either going to add or subtract to our x. We are going to add or subtract to our y. This moves right or left, and this moves up or down, just like you would expect. So to move from A to A prime, we're going right, so we're going to add whatever these h units are, and we would add whatever these k units are to each of the coordinates. So transformations is a matter of reading the graph, got to know your notation, original to new, and make sure it applies to everybody. So translate the figure by this rule. This rule tells me -3, go left 3, plus 2, up 2. So if u is at -2, 0, then u prime -2 minus 3 is going to be -5. 0 plus 2 is 2. So -5, +2, u prime. And you can see that we took this point and we went left 3 units and up 2. And so then it's just a matter of going through y is at -3, -4. Y prime will be -3 minus 3 is going to go to -6. -4 plus 2, -2. -6, -2. And it's okay that they overlap. P is at -5, -5. So P prime is at -8, -5 minus 3, -5 plus 2, -3. So -8, -3, here's my P prime. And W, my last point, which is at -6, -2, W prime will go to -9, 0, and it will be there. When I connect the dots, again, we can see how that figure was slid 3 and 2. Every point goes over 3 and up 2. So that's all there is to doing a transformation or translation. Our second example says write the rule. So we write rules like this. What's the recipe? What do I have to do to my x, and what do I have to do to my y? So when I look from m to m prime, what did I do? I went over and up. So from -6 to 1, I went right 5, and I went from 0 to 3, I went up 3. You can either do it by looking at the graph, or if you look at -6, 0 to -1, 3, how do I change -6 into -1? I add 5. How do I change 0 into 3? I add 3. So then I say +5 plus 3. And that's the rule. This is your answer that will transform each of these points into the other. And you can test it. -3, add 5, I end up at 2. Add 3 from -1, I end up at 2. And that rule holds to move the points to the appropriate location.